when we talk about the standard position angle, we're talking about the positioning of the angle. So we should be able to tell what quadrant we're in. And given the quadrant and being able to relate the sine to y, the cos to x, and the tan to slope, we should be able to figure out if the values are going to be positive or negative. So if I look at sine of 210 degrees, okay, 210 is somewhere over here in quadrant 3. Okay, so 210 being in quadrant 3, and we know that the sine value goes with the y coordinate. Okay, so the sine value goes with the y coordinate. We know that the sine is negative in this quadrant. And then we could do the same thing with cos. Again, we want to relate the cosine to the x coordinate. So first of all, we need to figure out where the positioning of 100 degrees is. 100 degrees is just past 90 degrees here. It's in quadrant 2. And the x position is going to be related to the cosine. So that x positioning is going to be negative. Okay, so cosine goes with x. The x position is negative in that quadrant. We go negative to the left to get to that point. And so the cosine is going to be negative in that quadrant. Taking a look at 300 degrees, we want to locate the 300 degree angle. So again, it's really important to know your poles here. So 90, 180, 270. So we know that 300 degrees is just past 270, so somewhere about there. Okay, so our positioning is in quadrant 4. And the tan is to do with the slope. Okay, so this is our slope triangle. We know our slope is negative going through there. So there's our negative slope. Okay, so we know that the tan must be negative. Okay, or the negative y compared to positive x is going to give us a negative ratio. Now with standard position trig, we can go beyond 360 degrees. So if we want to go 430, well, first of all, it's negative, so we're going to go in the negative direction. So there's our circle. We're going to go negative 360 degrees, and we need to go another 70 degrees to end up here. So that's the location. Again, the location of the point is what's important. That position is going to be located by that point. The sine has to do with the y positioning. Okay, so the y positioning is sine, and we know that the y positioning is negative in that quadrant. So we know the sine value is going to be negative. Okay, now to get the actual ratio, we have to plug it into our calculator, but right now we just want to locate the general positioning. Is it up or is it down? Okay, is it left or is it right? So that's really important when we talk about standard positioning. So here we have some general position, some xy coordinate in standard position, and it's in quadrant 1. And we can just draw in our reference triangle here. And we know that this position is positive x, positive y. And we can find the same positioning or the same reference triangle with different positioning in the other quadrants. So for example, in quadrant 2, I would be folding it across that line, and I will get this positioning right there. So that's my position, and I'll do a little bit better here, more like that. And the positioning, the x and y positioning, that gives us this different position, but with the same symmetry. We would end up with negative x and positive y. Okay, in quadrant 3, that same positioning, different positioning, but same reference triangle, same ratios, is going to show up over here. Okay, so that's going to be directly opposite of the black point. And so that point is going to go in the same distance x, but in the opposite direction, same distance y, but in the opposite direction. Okay, so we get that point. If we look at that last quadrant, okay, there's going to be symmetry here. Okay, and that the y position, x and y position, is going to be determined by what's going to be the same as a black x, positive. It's going to be negative y. So it's going to go to the right and then down to get to that same point. And all four of these points are symmetrical to each other. Now they represent four distinct different points, but they are all definitely related because of the symmetry of this circle.